Welcome to week 3 in GR, the course GR101, Introduction to Grade. This is Scotty, your instructor, and I'm going to immerse you into slopes and percent grade. That's a lot of what this chapter is about, and we need to get this. There's not a whole lot to understand. There's just a whole lot. So our next week, our module, we will be getting into slope stakes, and we need to know all of this information to navigate that course. And after that course, we will be getting into reference points to slope stake and some more advanced things that you would see on highways and things like that. So, let me start out by saying you're looking at a slope, not a piece of cheese. And it's these, the hardest thing on online is explaining three-dimensional objects that are not in 3 dimensions. But let's look at this slope. I need to let you know, when we're talking about a slope, this is the thing we're talking about. This is like, do you guys know what a profile is from like maybe a highway or a slab or something? It's where you would cut. Let's let this be a piece of cheese. Let's say that, maybe that'll help. I used to use a loaf of bread. If I want to know what this looks like from over here where you see my arrow wiggling, I guess I better get over here where you see my arrow wiggling. Well, that is the profile. This may have been at one time a big long loaf of cheese, but we cut it right here and ate the piece we cut. And this is what you would see left, right? After we cut that and devoured that piece of cheese, this is what you would see if it was a wedge-shaped long piece of cheese. So I'm putting this up here because when we're talking about slopes, this is what we're going to be looking at, the profile of a piece of cheese. So you got to keep in mind that this slope, which is 1 to 1, this 1.5 to 1, and this 2 to 1 slope has depth. It's not just a single plane. It has depth that goes away from us and comes toward us. It would be like a trapezoidal cube, let's say. So we could, I don't know, in math, have you had volume? Volume is going to be essential. If you don't know how to calculate it, you will learn during hydraulics, so have no fear. But this is what I'm trying to say. We'll be talking about slopes, but we'll just be looking at what is a triangle. But as you can see, a slope is a triangle. In the beginning, there was nothing here. This is all dirt, and it was laid down in lifts. Lifts are like 12-inch, nothing here. We come down with a scraper and drop a lift. We move over all the way and have a 12-inch lift from this point all the way back here. All of that bottom is 12 inches high, but it's flat right now. So the next scraper comes in, and let's say we're doing a 2 to 1 slope. He moves over 2 feet and drops a lift that's 1 foot higher. So he's gonna, it's gonna be a foot up, another feet. In other words, but it's gonna start 1 foot over this way. 2 foot over this way, and he's going to drop a 1 foot lift. All right, and that's going to happen. Another scraper is going to come by and start 2 foot over this way, drop another 1 foot. So what we're building is a stairs or bleachers, if you'd rather see it that way. There'll just be steps along here, and after a while, when we get, maybe it's in this module we're in this week, but we will have these little steps instead of a smooth slope. Then we'll come along here on a dozer with a slope blade, let's say, on it, or maybe we can get our motor grader up there. I don't know. But anyway, we'll cut those steps off, because the way you'll start is over 2, up 1, over 2, up 1, over 2, up 1. Bet you're tired of that. Over 2, up 1. So you will have what looks like bleachers. And but you'll end up with a slope. You just have to cut the steps off of it. And these will be how things are staked. These first stakes are staked first. Imagine that. And they're called toe stakes. We're talking about a fill slope here, not a cut slope. We're going up with our dirt. So this toe stake will tell you everything you need to know to go to the next stake, or actually all the way up, because when you get so high, you're going to put another stake in. And you'll put all these toe stakes in for a distance. You know, like if it's a curve you're going around and that slope's going around the curve, you will space them a little bit closer as opposed to the usual 50 to 100 feet, because you've got a curve to make. Now, you get say we've got it flat all the way up to here, so we need to go up again and again until we get up to this point, and it is going to be dependent. It could vary. If it's 20 feet up in the air, and this is 40 feet deep right here, we're going to have us 2 to 1 slope, by golly, because it's 20 feet, or yeah, 2 to 1, because it's 2 feet like here, 2 and up 1, 2 and up 1, 2 and up 1. So we'll have a 2 to 1 slope here. That would be, if it's 20 feet high and it's 2 to 1, it has to be 40 feet deep. It's going to say in some of the problems you come across the width. When they say the width, they're talking about the depth, really, how deep it is. And when you measure, you don't measure the slope from the top down the slope. You got to measure straight out and down. And there's a way to do that, and we'll get into that. But on the way up, we're staking it so it ends up 20 feet up here. It's up here 20 feet because perhaps there's a roadway down here, highway. And then you meet a farmer's pasture up here. So we've made a slope all the way up to the grade of the barbed wire fence to keep the cows in. And highways down here. Now this is just a section of a highway, of course. It would be going for miles. And this slope might continue on till you need it, until the highway reaches a level where each side is lower, and then you would do a cut slope going down. So that's enough about that. But I'm going to read a minute. It says, when an operator calls for grade, he just wants to know where the elevation of the proposed grade is in relation to where he's cutting or filling, so he'll know how much more there is to go and to get to the top of the field here, or how much more there is to get to the bottom. Now, let's see, we got some definitions here, and I've got too many highlights. I don't know which is the best. So the term grade has several meanings when an equipment operator calls for it. Proposed grade is such as where the top of the field or the bottom of the cut is located, the point where he or she is to begin the excavation or the end. You know, if it's going down. Unless the operator can visualize the level or plane at which the cutting or filling must stop, the the individual cannot hope to do the job. Operators know that when they have reached the point at which it is said to be on grade or at grade, they have completed the work. And remember, from week 2, we used that grade boot, and we went up or down and told that operator, like, you need to cut, if we were too high, you needed to cut 2 1/8 or remember all of that. That's where this comes into play. That stuff you're learning. This is all scaffold, they say. We've got to learn something before we learn something else. So their definition of a slope is a straight line between a high point and a low point. The point where the slope touches the ground is, our baseline is known as the toe, in this case right here. A slope may be produced by a cut or a fill. Slopes are usually referred to on a ratio of horizontal to vertical, such as 1 to 1, 1 1/2 to 1, 2 to 1, as shown in figure 30A right here. So 1 1/2 to 1, and I'll go over this one more time. This 1 to 1 would be 1 horizontal, 1 vertical. The 2 to 1 would be 2 horizontal, 1 vertical, 2 horizontal, 1 vertical, etc., etc. When you're expressing slope as a ratio, remember that the number to the right, such as in this case up here, is 2, is the horizontal. Did I finish reading it? And expressing slope rate, remember the number to the right of the colon is the vertical. That's that 1 you're seeing there. Every time we go 2, we go up 1. To the right is the vertical. And the horizontal is the figure to the left. You can see, he's talking about figures 39 and 40. We'll get there in a minute. So 2 to 1 is 2 feet horizontal and 1 foot vertical. 2 feet horizontal, 1 foot vertical. And vertical can be up for a fill slope, and be down, right, for a cut slope. Where the rate of grade is expressed as a percentage, now this is what we're doing here. We're talking about slope ratio kind of versus percent of grade. Where it's expressed as a percentage, the rate of rise is computed for a horizontal, not slant distance, not slant distance, horizontal distance of 100 feet. If the ground rises as you go higher in station numbers, this is called a +% grade. If it falls as you go up station, it's a -%. In other words, this is a -%. This is a +%. Up station usually means left to right, because most of your projects, especially roadways, are going to be laid out left to right. They may start 20 miles down from where the start of the road is, but they don't build the road in one day. They do it in sections. Okay, now I do not do long division anymore. I have a calculator. So disregard this. The formula for percent grade, let's see if they want to tell us. This, I'll get down there. The formula to find a slope ratio, such as 2 to 1, etc., is to take the desired horizontal distance and divide it by the desired vertical distance. In other words, the desired horizontal here is 2, and the desired vertical is 1. So you take the horizontal and divide it by 1, and you get 2 in this case, which would be 2 to 1. Okay? So far, so good. There is a bit of a issue here. I don't know if you've been exposed to a profile picture of a road as if you had cut it as we cut, I don't want to say this piece of cheese. So remember we just cut that one and moved it away. Well, here they took the road and did the same thing. We're looking as if this is all underground right here. This is the top of the road right here. This is your distance down or up station down the road. And this is the way surveyors do it. Like from somewhere, I don't know, back here to here is 600 feet. And you write that 6 plus 0, 0. Now, from here to here is another 100 feet because it's 7 plus 0, 0. So from that little information, we can assume that each of these horizontal distances within this grid are 100 feet. So, write that down somewhere or memorize it. I don't care. Just know that. Now, as we look, and this is all the horizontal, have you heard of stations? That's what these are, stations. And they're usually set at 100 feet. When they go around the curve, they may be dropped down to 50 feet from one station to the next. But they are always put down like this. If we want to know where station 850 is, 8 plus 50 is the way. This is station 800 right here. So we know each of these is 50 feet, so this would be station 850. Okay. Hope you got that. Now, same kind of thought process goes in these elevations. These are how far everything is above sea level. Like this point on our proposed roadway will be 250 feet above sea level because, am I reading that right? 290. So these are different. Let's make sure that I'm jumping ahead here. This is 270 feet right here. This is 280 feet. So these would be, let's see, that's 100. And you're saying that's 270. And this is 280 right here. So these are 10 feet apart. These little guys here are 50 feet apart. And the reason I'm changing my mind is because this is 270 and this is 280. So from here to here is 10 feet. So from here to here is 50 feet. Okay, I think we got that down. If not, we will come back to it. What we're needing to make sure of right now is that you understand this profile view. Everything below this line right here is under the ground. This is the top center line of the proposed roadway. It's a bit bumpy looking, but that's what it is. It says so somewhere down here. And these guys right here, they look like towers, don't they, of some kind? Well, they're not. They're manholes. And the reason they're little at the top and large at the end, when you scale a roadway, your horizontal distance will be at a different scale than your vertical distance will be. Your horizontal distance is going to be a long way. So your scale is going to be larger going this way. So when you're going up vertical, you're changed vertically, your scale vertically is distance. And that's why these will look like this. And I'm not going any further than that. I'm just telling you why they look like that. Because the horizontal is different than the vertical. And that's why they look like that. Now we have a little project here. If the slope, let's say slope, if the slope was 4/10 of a foot in a distance of 400 feet, the slope could be expressed, now we're going to percent grade, get ready, hold on, as 0.001. Now, again, this is obtained by dividing the vertical 4/10 by the horizontal 400. Do that. 4/10 divided by 400, right? Let's see what I get. 0.4 divided by 400. You will come up with an answer of 0.001. That would be your fall in this case, 0.001, because when you take 4/10 and divide by 400, that's what you get. What percent would that be? If you wanted to know what percent that was, you would multiply times 100, and you would come up with 0.1 or 1/10%. Now look at this down here. I know I'm skipping a little bit, but this is your, there is a pipe in here, and it's hard to distinguish it from the rest of the grid in here, but you can see the top of the pipe here and the bottom of the pipe here. Now what's important about this, we already know it's an 8-inch by 2 minutes. I don't think they use that stuff anymore, but that's okay. They still calculate the same way. It's saying this fall is 0.008. Now, we're talking about the same 400 feet, and you can see it goes from 600 to 1,000 right here, so there's your 400 feet. So this pipe is falling, is going to be put in here at a rate or fall of 0.008. If you want to know what percent that is, multiply that times 100, and you will get that's 0.8%. But let me tell you something. When we start this calculating, we change our percent to decimal forms because it's hard to multiply 5% times anything. So we change 5% to decimal, which would be 0.05. Now, because we multiply, we divide the percent by 100, and we will get 0.05. Now, let me see if that's true. 5%. I'm just going to put in 5 because it'll be a whole number. Divided by 100 equals 0.05. Okay? This divided by 100 equals, because it's 3 decimal, 0.8 or 0.8%. The most important thing when it comes to laying this pipe in at this fall of 0.00 or 0.8% is the bottom inside of the pipe, because that is the flow line. It's called the invert. It is the bottom inside of the pipe. It's the inside bottom of the pipe. The inside diameter is the bottom. It's where if it's a sewer, you know what's going to be flowing down through there. If it's water, you know what's going to be flowing down through there, etc., etc. So whatever, but we're assuming it's gravity flow, and that's why they put it in at this fall. So it will flow coming from here down to here. So let me move on. Figure 41. Note that the rate of grade is written along the top line of the pipe. On road plans, the grade line is written along the profile line of the finished roadway as shown. This right here. all of this. Now, we don't need to spend a lot more time here. You have up here the real deal. When you look at figure 41, it's telling you there's a slope. There is a slope in the sewer line of 3 2/10 feet between 600, station 600 and station 1000. Sorry, got lost there for a minute. 10.006 plus 0 there. There's 400 feet between there. Now then, let's take station, this one, 275 versus 271.8. Station 275, I'm talking not station, I'm sorry, elevation 275, difference between elevation 271. Here is 275 right here, and 271, wait, 275, this is 275, right here, sorry, here's 275 right here. And then 271 will be right here. 275 goes all the way over to here. So it's going to fall from 271 right here, going all the way up to 275. So the difference in these two, I think it's 3.2. Let's see. Station 275. Minus or plus, in this case minus, minus station, not station elevation, 27, elevation 275 minus elevation 271 equals, I made a mistake. I forgot the 0.8. One more time. Elevation 275 minus elevation 271.8 equals 3.2. So in this case, from here to here, we have, they're sticking with the top of the pipe, I think, but you should be worried about the bottom. They have a fall of 3.2, and it's over 400 feet. Now, to get a vertical percent grade, the formula is vertical divided by horizontal. So the vertical distance, up or down, in this case down, is 3.2, as you see up here. They agree with me. So the formula is 3.2 vertical divided by horizontal 400. So 3.2 divided by 400 equals, again, 0.008. Or, if you want to talk percent, which you don't, it's going to be 0.8%. So that's how they know what this fall is going to be. They calculated it by subtracting those two elevations that they wanted, the engineer wanted. The high one, which was 275, and subtracted the low elevation 271.8, and that gave them a vertical distance of 3.2. So to come up with this 0.008, you take the vertical and divide it by the horizontal. 3.2 divided by 400 is 0.008. That's where all that comes from. Okay. Yesterday, I was doing this, and my sound messed up, so I had to redo it, but I still have some yesterday notes. I think maybe that we can use without adding more notes. Probably not. I don't think we have the same, but we can use the sheet of paper, can't we? All right. We're going to make a shift here. We're going to look at my hand for a minute, and I'm going to see if I can't do it right now. Hold on. Turn that off. Turn this on. Whew. There we are. So I said, feel free to write this down. You will use it over and over again. I said that percent grade, P-E-R-C-E-N-T equals the vertical divided by the horizontal. Slope, the ratio can be found by dividing the horizontal by the vertical. They're inverts. The percent is the invert of this. I don't want to talk about that right now. We don't need to know anything about that. So again, we had a vertical of 0.32, if I recall, of 3.2. And we had a horizontal of 400. And that equals, once again, 3.2 divided by 400 equals, that equals 0.008, or 8%, if you multiply it on out. So that's where that came from. Percent grade, write this down, is equal to the vertical divided by the horizontal. What if we didn't know the vertical? What if we didn't know what that was? We do. But what if we didn't? And we had to find it. So one of the things we could do is algebra. We could say x equals, no, we could say we don't know the vertical. Percent grade is 0.008, 0.008. That's percent. That's the percent grade, which is we'll leave it in decimal, but it would be written down as by percent, 0.8%. So we don't know it. So we'd have to move some things around, right? The vertical, we don't know. Right here. But we do know the horizontal, right? And we do know the percent grade, right? So we do know this. We just don't know the vertical. What would we need to do to find the vertical if we knew the percent grade? I kind of know out of my head, but let me show you something else. Look at this. These were created by other people, but they sure do make a difference in my life, and can in yours. As you can see, I've played with this over here. Well, and my eraser got extremely dirty. I think it's because of the type computer paper I'm using. It's quality, so it smudges up. But if we look at percent grade, vertical over horizontal, and we have been given, we don't know this. I know what to do over here. I would take this percent and multiply it times 400, and I'd probably get that. But just say I don't know that. I don't know algebra. When you get into slopes, you'll have to start moving things around, and when you take a value across the equal sign, you have to change its function. Like if it's a divisor over here, when it moves over here, it becomes a multiplier. This circle takes all of that thought process away from you. Just go over here and put 3. We don't know the vertical, so fine, but we do know the percent grade, and we know the horizontal is 400. So this tells us to multiply 0.008. I'm getting ready to do that. 0.008. Did I do that? Yes. Times the 400. Guess what that equals? And this is all feet. You'll be dealing with feet or decimals of a foot, like 3 2/10. Or 3.2 is 3.2 feet. You know, when we're always dealing in feet or decimals of a foot. You got that? Now, if we go down to slopes, the deal is the same. The horizontal is divided by the vertical to get your slope ratio. Now, I'm going to take you through an exercise here. Given this, I don't think we have any percent grades in my little practice questions, but you can play with this. Just pick a percent grade, you know, pick a vertical, and it'll give you the horizontal. What if we took 3.2 and divided by 0.008? Do you think we would get 400? It doesn't seem like it, but boy, when you divide something by something really small, it's surprising. So let's take 3.2 and divide it by 0.008. What do I get? I get 400. Isn't that something? So you can use this in both slope staking and percent grade. Now that we've done that, let me see if I can find this thing. Challenge number 2. Go find something. I don't have mute in my video thing, sorry. Let's go, where do I want to go? Let's go back to the module. I think that's where we were. So we have to turn this off, and we have to turn this on. Now, let's see what I can find here. Have I got the things I want over here? Yes. One of them, anyway. Here's some practice bars, because you're going to get quizzes just like this in this module. If I make it bigger, the pixel thing on this other screen may make it harder, but let's see. That's not too bad. Let's see. These are random questions from throughout this great big operating engineers training manual I have. So look at number one. This is, I'm calling this slope ratio versus percent grade practice questions. If you've got a piece of paper, my goodness, this is an opportunity for you. On a 1.5 to 1 slope, the vertical cut is 3 feet. The vertical is 3 feet. What should the horizontal distance be? Well, if we go back to that, I wonder if I can get two things up there. Just give me a minute. I'm going to have us out of a job here in a proper quickly, maybe not. Let's move this guy over here. Let's see what other things. Where'd he go? Let's see if we can move this guy over here. I have moved him before. Do I need to make him bigger? I'll do this one. Oh, no. That's not going to work. We're just going to have to, I don't know. Ooh. Okay. This first one, on a 1.5 to 1 slope, the vertical cut is 3 feet, but we don't know the horizontal distance, do we? So what goes where? Well, look over here. We're dealing with percent grade, and it's unfortunately doesn't say that. This is percent grade, which is this is percent grade. Look at me contradict myself, because see, this is horizontal divided by vertical, so that tells me that's percent grade. This is slope because it's vertical. I'm sorry, I got it backwards. This is percent grade because it's vertical divided by horizontal. This is slope ratio calculations because it's horizontal divided by vertical. You know it's percent grade because vertical is usually going to be smaller than your horizontal. So if we put on, we've got a 1.5 slope, so we've got to use the slope ratio. I'm sorry. That means we've got to go, because it's saying slope here. We're not using this. So let's go down here to slope. We know the ratio is 1.5, so 1.5 goes where my hand is. Can you see? Yeah, you can see my hand. Goes in this little quadrant right here where it says ratio. What is the ratio? Well, it's 1.5. That's 1.5. What is the vertical? Do we know? 3 feet. So that's 3. So that's 1.5. Look at this. Times 3. That's about 9, isn't it? Something like that. 1.5 times 3 equals, no, 1.5 times, did I say the cut was 3? On a 1.5, so the vertical cut is 3 feet. What's the horizontal distance? So 1.5 times 3. The horizontal distance is 4.5. That's a little bitty slope, but it's 4.5 this way, and it's 3 feet this way. Horizontal 4.5, 3 feet. Look over here again at number 2. Which of the following have the same relationship as 1.5 to 1? Okay. The way to do this you'll come into this not all the time. But look over here And kind of what I do is see what's going to be the same as 1.5. We're looking over here what ratio is the same as 1.5 to 1. I think it's 6 to 4. And the way I do those things is I take the horizontal and I divide it by 4. But let's rule out 3 to 1. Is it 3 to 1? No, because that it's not the same. It's not going to be 1.5 to 1 either. I can tell you that right now, because that's 1.5. So what's the only thing really logical? Take 6 and divide it by 4 and see what you get. 6 divided by 4 equals 1.5. So the ratio 6 to 4 is the same as the ratio 1.5 to 1. They're the same. The values aren't. I mean, you know, a 6 to 4 ratio will be the same slope or incline as 1.5 to 1. That was just an oddball question, but if you'll see it again, you kind of have to rule them out by just taking whatever you can and divide the horizontal by the 1. In your questions in that quiz, I don't think there's but one of these, and I think this is it. Moving on, if you have a cut, we're still talking about slopes, I think. If you have a cut of 4 feet in the 4 to 1, that tells you we're slope. What would the horizontal distance be? Well, we have a vertical of 4 feet, so it would go here. We have a ratio of 4 to 1, so it would go here. So if the vertical is, the vertical would be your cut is 4, and the ratio is 4. This is telling me to multiply the ratio times the vertical, so the ratio is 4 times the vertical of 4, so your horizontal is 16. Let's do another one. These were actually multiple choices, as you can see, but it didn't work well when I was trying to snag them over here. And but that's okay for now. Your test will not be a little vague like this one. It'll be clear, but at the same time. So this, yeah, we did that. At the top of a slope, you have a cut of 17.8. That's your vertical. Your cut is 17 8/10 feet. You have a 1.5 to 1 slope. What in the world is the horizontal? Well, your vertical is 17.8. Let's write that down. Vertical equals 17.8. The slope ratio is, where did it go? The slope ratio is 1.5 to 1. So slope equals 1.5. So what does this tell me to do to find the horizontal right here? Ratio is 1.5. Vertical is 17.8. You take 1.5 times 17.8. You have a horizontal distance of 26.7. And actually, it's in here as one of the options. So, did you see how I did that? I'm just following my circles. I'm not trying to do math. I'm just plugging in things where they go. We have one more. Now we have a horizontal distance of 13.5. So that would go up here. Let me write it down. Horizontal 13.5, and we have what else do we have? A slope of 1.5. What? Oh, what would it, if you had a horizontal distance of 13 and a half at a 1.5 to 1 slope ratio, and you could not read the cut, what would it be? Okay, so the vertical, we don't know what the vertical is, but we know that the ratio is 1.5, and we know that the horizontal is 13 and a half. So this tells us to take 13 and a half and divide it by 1.5, which is the ratio. I'm going to do that. 3.5 divided by 1.5 equals 9. And look here. You got 9 for the vertical, right? We had 13 and a half. For the horizontal, we had a 1.5, and now we know we have a vertical distance. Its slope's going to be 9 foot high. So we took the horizontal divided by the ratio. Remember, you can do the same thing with percent grade. I just didn't really do it a lot. You can take the vertical right here on percent grade. If you know this, and you know either one of these, if you know two things, you can find the other. If this was a percent grade of 0.02 and this was vertical of 4, I would take 4 and divide it by 0.02. 4 divided by 0.02 equals, look at there, my horizontal would be 200 feet. Now take 200 feet and multiply it by 0.002 to check yourself, times, no, I said 200 feet times 0.02 equals, wait, I'm in two different places, sorry about that. Let me go over it one more time. We have 13.5, we have 1.5 to 1. What it would be. Okay. If you had a horizontal distance of 13 and a half at 1.5 to 1 and you could not read the cut, what would it be? We already did that, I think. The horizontal is 13 and a half. The ratio, so 13.5 on 3.5 divided by 1.5 equals 9. Yeah, that would be a 9-foot vertical. So I could go on and on. I hope you get the message. There's a little bit, one more thing I can do. If you got the time, I got the time. If I can find this thing, I'll try to run through this. Take a picture of it if you want to keep it. Or I suppose I could put it in the module, but I just wanted to talk more about it. This is some things I worked on this too. I may have confused it, but this is a very descriptive and deal here. It gives you the definition when I'm talking about slope ratio versus percent grade, just to be formal about it. And by the way, slope ratios are usually used in steep inclines, such as back slope of a highway. In other words, when you cut through a hill on each side of the road, there'll be a big back slope. And they'll be like 2 to 1, 1.5 to 1. Percent grade is usually preferred in smaller inclines, such as a gravity flow sewer system, and we just did that, usually around 0.02. So the thing about knowing this, if you're as an engineer, or just to know it, you know, the steeper your slope when you're building a roadway, the smaller the right-of-way you have to purchase. Now you know why. because a 1.5 to 1 slope has a lower horizontal dimension than a 6 to 1 slope. 6 to 1 slope would be a long horizontal, and the horizontal from the very back of the slope to the edge of the or center line of the roadway is what's at stake when you're buying right of way. So the steeper the slope, the better financially for if the state's doing it, them. But also, the steeper the slope, the more likely, if it's not solid rock or some kind of type A soil, the more erosion you're going to get, or it's going to be harder to maintain, because a 1.5 to 1 slope, you're not going to brush hog that, dude, without tipping over. I don't think. That's a pretty steep slope. So, but mostly it's to keep it as steep as you can, just because you don't have to purchase much right away. I'll send this to you guys, or maybe I'll put the whole thing in the module. I'll decide that. But hope this helps. Be sure to call me if you have questions. This is it's a pretty good read. I don't want it to confuse you, and I don't really want to take any more of your time up. But read through it. When I figure out a way to get it to you, I'll call it. If I put it in tangents, I'll call it slope ratio versus percent grade, and put it in there as a file, and you can open it and read it. Let's do that. I'll do that, because you may be able to copy it. But this guy right here, where did it go? If you didn't do it yet, you ought to just draw this so you can have it, because this keeps you right on task. And believe me, you're going to be, before you get through this module, you're going to have some questions that, like we just went through. Most of them, but not all of them, will refer to slopes. Some will refer to percent grade. But realize right here, you've got the magic key to either percent grade or slope manipulation, calculation, whatever. Okay, I'm going to shut it down for now. Ready or not?